just want to see if anybody's listening.
All right.
Everybody got caught. Keep going up, Bill.
Real late at night.
Everybody got cards. Woo. It's going to be a good time. Hopefully this is back by Wednesday. We'll find out.
And then he goes over and starts doing all these tricks with cards, and it was just like the coolest shit I've ever seen. The guy was like, he mastered that team behavior.
Yes, please do.
Yeah.
Please do.
Yeah.
Please do. Please do. I'm going to find the frequency. Part of that's a vibrator.
I feel like we're in an episode of The Office,
I wish I should sing that like words out of my mouth.
I just get the same.
You see this okay?
And then this. You said the camera.
Oh, there it is. Welcome to 105. Hi. Good afternoon. This is a weird ass room. So hi, on the camera too. Had some people that couldn't make it today. We're gonna try to record. Sorry for the voice. Hopefully it comes back by Wednesday. I lost it on Saturday. It's been many, many years since I lost my voice like this. Ask Jessica, she knows how loud I am. Much louder. What's that? Yes. Yes, I'm trying to forget. So 105, this is awesome. This is totally awesome. For how many of you is this your last math course? Ooh. Why do the rest of you look so unhappy? Yeah. Who needs stats after this? 243. Stat 243. No? Maybe.
That's statistics?
Yeah. Sorry. We're gonna learn a new language today, Sean. Sweet. Yeah, stats. Yep. Who else needs stat 243? Anybody else besides Michael? No? What else do you need if you're not done after 105? Or are you not sure yet, maybe?
I'm not sure yet.
Not sure yet. Okay. You'll talk to your advisors, though, right? I'm hoping to talk to your advisors. We'll do a little bit of that halfway through today, too. I want to make sure that you're all in the right class. If you came out of 98, you definitely are. This is exactly the course you want to take after 98. That's why we built 98, was to send you into 105 with a set of skills. I'm going to sit here. It's a good idea. But I wanted to start today, rather than just doing the normal like which we'll do in a little bit. I gave you all deck cards because of a question that a former student of mine, he actually now works at COCC, sent me this many, many years ago. And I want you to ponder it. Can you see this okay? Is that readable or no? We read that. Take a look at that. Steph, can you see that?
Well, I do have my glasses, so a little bit better than
A little better than usual, that's good. Every time you shuffle a deck of cards, like the one you have in front of you, that's kind of crazy. It's probably the only time ever that any deck of cards has been in that order. You need a deck of cards. You cannot do today without a deck of cards. And then JT, my buddy sent me this note. What do you think? I find it hard to believe. So I'm going to start by asking you, who needs cards? You need cards, all right. Who else needs cards? Yeah, no.
No, we share.
Oh, no, don't share. Because you got to play a game later.
Okay.
You got to play, oh, no. You don't share it. You know, on the deck. Talk amongst yourselves. Amongst my names. If anybody notices they're missing cards, let me know. I think you lost.
I'm sorry, I said that, but.
Now, dear friends, I just gave you a form. Something stuck there. I swear to God. Say sorry. Give me a second, everybody. Hey, everybody. Usually I'll just yell and you'll hear me. Steph will tell you. I just gave you a warm-up. I just gave you a warm-up. We're gonna start every day with a warm-up. And we figured, might as well start today with that too. It's real quick. Always gonna be 5-point questions. Or 5-point warm-ups. Put your name at the top. First question is, do you believe the claim? I made it larger so you can see it better. Every time you shuffle a deck of cards, probably the only time ever in any deck of cards through that order. Yes or no? I guess we can add a third option too. Yes, no, maybe unsure. That's probably yes or no. Because we're gonna chase it down. And then the question often comes up, and I heard it as I was walking around. How many different ways do you think there are to deal out an entire deck of 52 cards? Because the idea is, you take a deck of cards, just right here. Cards. Shuffle them. And then if I deal them out, across the floor. That's an order, correct? That's one order, whatever order these cards are in. How many different ways are there? Throw a number down there. I don't care what number you put. Just any number. Any number. If you can't calculate it exactly, don't worry. It's the best part of this movie. I just want you to talk to each other. What's that? Okay, first things first. Is this recording? It is. Raise your hand if you do not believe that. If you do not believe that claim, you do not think it's the only time. Who says, yes, we do believe it? Yes, we do. Oh. That's fun. 17 markers suck. I'll be right back. I want to hear some numbers in a second. I need better markers though.
Yeah, no, it's fine.
Yeah, you have, there's no way to do it. Yeah, it would be impossible. But I don't necessarily think that it's I doubt that
It does have a lot of weight. Probably 10.
That's like just higher than like.
Oh, a lot, okay.
So actually, yeah, I believe.
That's interesting. Okay. For those of you that said you don't believe it, tell me why. Tell me why you don't believe it.
Just because like the amount of cards that
it's
are
something
shuffled in the
like
world,
8
it's
times.
millions of cards that are decided every hour.
Yeah, so if you think about how many decks of cards there are in the world in general, millions, billions.
If 8 factors, if 52
Is there a deck of cards for every human being on Earth? Okay. Okay, all right. I like this, I like this. So no, we don't believe that because that's just too many cards. Too many decks of cards being shuffled. Who says, who agrees with that? That seems feasible. There's too many decks of cards, there's too much of a chance of overlap. Yeah. Does anybody not believe it for a different reason? Or is that pretty much the main reason? It's gotta be repeated somewhere. Okay. For those of you that believe it, that's true in your opinion. Why? Why do you believe it? Talk to me.
I know a Rubik's Cube has 43 quintillion different possible, like, outcomes when you scramble
I
it.
love that you know what a Rubik's Cube is. As someone who was alive in the decade when they became a thing. Holy crap. Who in here does not know what a Rubik's Cube is? Oh my god! Holy shit, everybody knows what they are. Who knows who Cindy Lauper is?
we're not.
Who knows who Cindy Lauper is? See, that's Rubik's Cube, Cindy Lauper, same years. How do you know what one is and what the other one isn't? It's mind-boggling to me. You all know what Rubik's Cube is. Everybody in this room. But only 7 of them know who Cindy Lauper is. Okay, tell me Rubik's Cube. Quintillion.
43 quintillion possibilities on the Rubik's Cube when you scramble it.
How do you, just out of curiosity, how do you remember that? Just,
I'm just into Rubik's Cubes.
quick, give me that number again. 43 quintillion.
Yeah.
Thousand. Million.
Yeah.
Billion.
Question isn't big, it says probably is.
Trillion. Quadrillion. Quintillion. So your claim is that a deck of cards
I think would have more
would have
outcomes
more
when
than
you
that,
scramble.
based on what?
Just that the Rubik's Cube, it has the different pieces, 9 on each side.
Okay,
And you
got
add up the 6 sides with the 9.
it. Got it. Think about
And
the
then
Rubik's
the
Cube.
Rubik's Cube, all the pieces kind of connect
Yeah,
together
they
to
do.
limit how many
Yeah, there seems to be a lot more.
I
Okay,
think there'd be more possibilities with a stack of cards, and that's a very good number.
so let me ask the folks that doubt this claim, how do you refute that claim? Those of you that said there's too many decks of cards out there, too many shuffles, Well, we now got a Rubik's Cube, I'm trusting your math here. Rubik's Cubes have 43 quintillion possible arrangements. This likely has more, based on
Just a guess.
guesses, because the 52 cards versus,
I could be way off here. You
what's
can have
9
my
times
left.
54, 27 cubes, right? There's 26 cubes on a Rubik's Cube. Because it's 27, but the middle's not a cube, it's a mechanism that holds it all together, so. So there's twice as many things. Those of you that don't believe this, how do you refute that? Out of curiosity. I love this.
Well, deck of cards has been around way longer than Rubik's Cube,
True.
so it's had more time to achieve all its applications.
Ooh. Oh, which actually goes more with his, right? So do you believe the claim or do not believe the claim?
I do not.
Oh, you do not believe the claim?
Maybe the first time that specific decks do that order, but not as games.
Okay, I like this. Oh, I like this very much.
Especially considering when you get around.
Well, that's true. And I'm not talking about a brand new deck of cards that all come in the same order, right?
Yeah.
Whatever order that is, they're always in the same order, like diamonds, spades, hearts, clubs, whatever. I'm talking about shuffling. I read somewhere once that you take a brand new deck of cards and take 6 perfect shuffles to get them completely randomized. But that's what I'm talking about, the completely randomized. Talk to me.
So I feel like with the amount of possibilities there could be with every shuffle, or like however many there you can get, right? I feel like it wouldn't even amount to 1% of what
Oh my goodness.
the actual
Okay.
possibilities could be.
And that's a beautiful segue, thank you. Number of ways to deal out the deck. Let me just hear some numbers here. And literally, I don't need an exact number. For number 2 on your warm-up, I asked you how many different ways you think you can build these things out. I saw 52 over there, that was one number I saw. Somebody said 2,604, I think you're talking about that, or you were in the middle of the calculation, you were doing something else. I love it, 140,608.
Would have to be that.
8.06 times 10 to the 67th.
8.06 times 10 to the 67th.
Yes.
There we go.
Give me some others. No, what did you put for number 2 on the line? How many different ways can you deal the decks out?
100 sextillion.
100 sextillion.
Has numbers.
Sextillion, that's 5, 3 more than that, right? I think that was right.
I think that's right. It's a lot of zeros.
Give me one more. You do Price is Right rules. Wait, okay. So y'all know where it was genius. But 7 of you know who Cindy Lauper is. Better off dead. You don't care. We have the same brain. You and I think exactly the same. Okay. These numbers are all over the place. I mean, take mine out here. Those are ridiculous. They're all over the place. 52, 140,000. This, that. Part of what makes this an interesting problem, I think, is that it's very hard to comprehend how many ways there are to deal that deck of cards out. So I'm going to recommend that we do it slightly different way. Take 1 card out of that deck, just 1 card out of that deck. We're going to break this down. We'll turn this off for a second. We're going to break this down into a series of cases. A lot of times when I'm doing math problems, Math 98, last term, there was that fun lab we did about how we're going to die in this room. This was actually the room I was in when we first had that idea, 5 or 6 years before COVID. Kids were in this room, like, if we actually got stuck in this room and the doors all closed and the windows were sealed, how long until we died? This is what my students think about. But many things that matter. And it was a hard math problem. In order to solve that, I had to break it down to a simple math problem. And I kind of learned that very often that's the best way to do something. Break it down simpler. So let's look at a much smaller deck of cards. A deck of cards this damn board. You push this out, you guys push this out way if you want to. And then how about possible deals? Possible deals. Okay, so you got one card. How many ways can you deal that one card out?
One.
That's it. One card, one deck. That's it. It's boring as hell, isn't it? But at the start, one card, one way to deal it out. Boring as hell, but it's a start. Add a second card. Shuffle them. I want to hear you shuffle. Very shuffle. Good. How many ways can they be dealt out? Here, two different ways. Yeah, I think that's right?
Yeah.
This one, that one, or that one. Those are different orders, right?
Yeah.
If you're playing cards with somebody, if you got the ace of spades versus the five of hearts, that's a different value. So two cards, there's two orders. Thank you. Add a third card to that deck. I got a jack of spades, ace of spades, I got 21. I got blackjack. Five of hearts. Shuffle. It's hard. Alright. Talk amongst yourselves. And figure out how many ways you can shuffle, or you can deal out those three cards. How many different ways can you deal out those three cards? 17.
You got all
We have our first number.
No, I think
I got 17, I've got 6.
this one first. So 9.
9.
9 or 12.
Right. I mean, there's Here are the answers I've been given so far. I've heard 17, 9, 6,
5,
and 12.
6.
Do we have any different ones other than those?
Not any other way to
I've heard 9, 6, 12, 17, and that big ass wall just moved. There we go. The church traumatizing me. I got stuck over there. It was awful. I was a much younger man. That was back in Andrew, not anymore. Any other numbers? I think it's 6. We think it's 6. We like double down on 6. We like 6.
Yeah.
We like 6. We like 9. Oh, I like both those numbers. I like 12. I like 17. Let's figure it out. Let's figure it out. Now, I'm going to bet that all of us have different cards because of how we decided to deal these things out. So, rather than use my 3 cards, you know, Jack, I'm just going to call them cards A, B, and C. That way we all have the same. Is that cool?
Yeah.
Turn the camera too, so folks playing the home game know what the hell's going on. Okay. So, with 2 cards, it was A, B, or B, A. Those are the 2 orders for 2 cards, right?
Yeah.
For 3 cards, second puberty. 1 order would be ABC.
Yes.
It's a little tiny air vent. There's 1 order. Give me a number.
ACB.
ACB. That would be like taking the 2 cards over here and just swapping.
Yeah. And then there's BAC.
I heard BAC, I also heard BCA.
And then there's
CAB.
CBA.
and CAB.
CAB. 6, right? Are there any other possible ways to move them around, other than the ones you already have? What do you think, yes or no?
I think no.
I don't think there are any, I think we're done, yeah. I think we're done with this. Because I was, Journey, I think you were saying the first card could come out this way. So this is the 2 ways. You can start with A. This is the 2 ways you can start with B. This is the 2 ways you can start with C. And notice the difference. I like how you all did this too. It's kind of systematic. You want A, B, C, and then you want A, C, B. So you fix that first card, and then you switch the back one to get the left, right, right, left. And then you do the same thing here and here. So it looks like, I think anyway, that with 3 cards, there are 6 ways. 6 ways to deal them out. Add a 4th card. Add a 4th card. Oh, yes. Make sure you shuffle. I'm a proper shuffle too on this. The Sean shuffle crap. Give it to you, totally shuffle. Just being nosy. Ooh. You didn't want it. All right. 35 people. We have an extra. That's because I can't count. Thank you. There you go.
Should be 24.
Explain yourself, sir. You okay back here?
Each of these cards can be the first.
Again.
Can they go, can each of these cards go first?
Explain that. I've learned the concept before, and I forgot why. I know math.
Letters in starting with C. And then the second one.
That's quarter to 4 times.
I don't even know.
That would equal 4 3
It's okay. Yeah, partly it's because of the time. The other one is the state change. Give me some numbers, y'all. I hear 24. I heard 24 twice actually. 24, like 24. I heard 16. I heard 16. I heard 16. 12. After 24. Give me a thumbs up for 24. You like 24? Sure, just like 24. Okay. Give me a different number that you like better than 24. 16. Let me ask, why 16 if you don't mind me asking?
I just said because I feel like with the just one way starting with A, you can switch it around 4 times, so then times the 4 cards.
Ooh, I like that, actually. Let's go, use this board. Use this board. This one. There we go. If I write on this,
the way it works.
I saw once, they sell like a GPS chip you can wear in your shirt pocket.
Dealing it out.
And as you walk around the room, the camera follows you, which is great for ADD people like me.
And then explain that.
Okay,
Deal there.
I love what I just heard over there.
And then for the next.
Let's suppose we start with card A.
So,
Ooh, just A. What could happen here? A, B, C, D, yes? But that's not the only thing it had with card A in the front, right? What else could it be?
A, B, D, C.
Say that again.
A, B, D, C.
A, B, D, C.
Yeah.
What else could happen? Could anything else happen?
A, B, C, A, B.
I think we're done with B second, aren't we?
yeah.
Because now, this is starting to looking over there. starting to look like that, isn't it? Yeah. So then what could be now? A, C, D, B, or maybe A, D, C, B.
Yeah.
Are there any more?
B, C, B, D.
If I may, no disrespect intended. I'm looking over there at that one over there. I'm gonna put this C and this B and D next here, if that's okay.
Yeah.
Because that keeps the C pegged here. But what else could be in that second spot besides B or C? Could be D, couldn't it?
Yeah.
So it could be A, D, C, B, or, that was like a full volume noise. The words, it was like a different part of my windpipe. B, C, oh yeah. So, are there any more? Yes. Oh, well, I mean, sorry, let me rephrase that question. Are there any more with A in the front?
No.
I think we got them all, didn't we?
Yeah.
Because if we think about this, if you think about this, these 6 right here are just like those 6 over there.
Yeah. Yeah.
That kind of makes sense. So we could replicate this if we put B in front, couldn't we?
Yeah.
If we put B in front,
Yeah.
there'd be 6
Another
more.
6.
Yeah. And if we put C in front, there'd be 6 more.
Yeah.
Is that fair? And if there was D in front, there'd be 6 more. So if there's 6 with A in front, 6 with B in front, 6 with C in front, and 6 with D in front, how many are there altogether? Sounds like 24 to me. Now, I have to share with you, I wish I remember the student's name. I had a student, this teaches class in the library, which is hilarious knowing how loud I usually am. But I remember this one student said, I don't understand anything you just said. I said, cool. She's like, this is how I got 24. And I thought this was brilliant. She started over here with those 6. And she said, one thing you could do is put D in front of all of them. D. All right, the pen that works first. Put D in, oh, thank you, thank you. Put D in front of all of them. And that's 6 right there. D, A, B, C, D, A, C, B, and so forth. And then she said, now, put the D's here. So cool. That's 6 more. Then, put the D's here. 6 more. And then put the D's at the end. And there's 6 more. You get the same ones we got, just not in the same order. I thought that's so damn cool. I've asked every math person I've met since then, whenever I talk about this with anybody, I ask them, has anybody ever thought about doing this math this way? Nobody's ever said yes. And I wish I could remember that student's name. It was before COVID. It was like 5 or 6 or 7 years ago. And I used to email them every term. And like, I told the class about your idea again. And she's like, you don't have to leave every term. It's really cool. I love that you geek out with it. You don't have to tell me every term. Okay, good. Good. But using either her idea or this idea, can you figure out what it would be for 5?
120.
Say sorry. Okay, you got 120. How'd you get 120? Steph, tell me what's on your mind back there.
I was just saying Cesar got it. That's what I said.
Oh, okay, sorry. Oh, Cesar got it. Got it.
Yeah.
Okay. So what y'all probably say at this point is there's a bit of a pattern. So y'all say this is 120, yes?
Yeah.
Thank you. And the reason you got 120, right, so you took this 24 from up here and multiplied it by 5, which is the number of that 5th card we just added in, right? Yes, and then it goes backwards, doesn't it?
Yeah.
That same pattern can go backwards. This 24 right here is like the 6 times the 4. Let me color code a little bit, hang on. Actually, let me write the pattern, and then we'll color code. This 6 is 2 times 3, and this 2, technically speaking, is really 1 times 2. So let me see if I get a little color coding on it. I have a little blue, did I have a little blue pouch of marker somewhere on these back desks? Where the hell did I put it down?
Yeah.
Is it back there? There it is. Son of a bee. This is my good markers. All the colors. All right. So, we call these the card numbers. You'll notice that they show up as a pattern, don't they? They show up right here, there, technically here too, right? Technically.
That's how I was doing it.
Sure, absolutely. And then this number here comes from the line before. So this guy and that guy are the same. This guy the same. That guy the same, and so forth. Awesome. There's only one tiny problem, and it's a very small, teeny tiny problem. How many cards do we actually have in our
52.
deck when we started?
52.
52, right? Two cards, right? Thank you. Excellent. What's the small problem in order to get this number right here? What's the small problem, my friend?
The way we're doing it, we'd have to go through with every card, and that's a lot of math.
Damn it! The way we're doing it, in order to get 52,
We have to get 51.
we'd have to get 51.
You could code
Would we
it
not?
to be
Because
a
remember, our pattern is awesome. Part of it's very straightforward. The number of cards is multiplied, right? 52 over here. That's the 52. The problem is this number came from the line before. So we have to get 51. Which means we have to get, what else?
50,
Which means we have to get,
48.
which means we have to get, so let's keep going. Let's keep going, y'all.
No,
We better get, was that a groan I just heard?
no, I said
Steph, was that
no.
you?
No.
Well, I think it might have been.
No, I said
Oh, you,
no.
Sean.
Yeah, we're not doing that.
I think it's like 15,000 something. Because
It's a pain in the, we're not doing that. We are definitely not doing that.
You could probably code a bot to do the pattern for you.
Say that again.
You could probably code a bot to do it.
You know what's
for
funny? When I taught 105 last term, one of the last topics we did, and we'll do it here too, is financial math. The math of savings accounts. You know, if you invest this much, this often, at this rate, how much you're gonna have after this long. And one of the kids is like, why do I have to study this stuff? I can just use AI. I'm like, let's do it. Let's friggin' do it. So we put my problems into ChatGPT and it totally shit the bed. 10 times. Until we taught it. Like we taught it, like, no, you didn't mean to do that. Like it's really cute. Like it's like, oh, I'm so sorry, I did it wrong. You've used this, right? I think it's fabulous. I think those things are great. But what's so funny is they're still in diapers. They're not quite there yet. We had a guy apply for, our department's very low in faculty right now. We're only 7, we used to have 12. And we're hiring for people, which is great. One of the guys came in and said, here's a question that ChatGPT can't answer. And it was a fun little problem. I might give it to you all later and have you run through ChatGPT and see what it says. And it was funny. Like, it's not good at doing certain kinds of math. It's great at writing papers from what I hear. But it can't do, like, basic math sometimes. Yeah, my friend.
Could you go all the way to 26 and then double, because 26 is half of 52?
Can we come back to that in like 4.5 to 5 minutes? And if I don't, you remind me, because I love that question so much. Is that cool?
I mean, we did the same thing in '98 with the DICE project, with the bot.
yeah.
I stopped using that project then. I don't use it. Steph didn't see the DICE project.
Really?
No, see, I've rewritten that course since you
Never
took
took
it.
a DICE project.
Yeah, I read that course a lot. I'm constantly tinkering, so. We did do something similar, you're right. So I'm doing this, we did do something in '98 with the math involved with this. It's just you might not see it yet. Chuck over here. Hi, Wendy. All right. I'm gonna write this a little bit differently. Instead of 1 times 2, I'll write it 2 times 1, if that's okay. Is that legit?
Yeah.
2 times 1. If you switch the multiplication, it doesn't change it, right?
Yeah.
Awesome. So 2 is 2 times 1. I'm also gonna switch this one, if that's okay with y'all. I'm gonna make this 3 times 2. Is that okay?
Yeah.
That's okay. I used red yet, I used red. Forget colors. You see that 2 right there? That 2 is the same as that 2 right there. There's 2, correct?
Yeah.
And 2 is 2 times 1, is it not?
Mm-hmm.
So really, this is just 3 times 2 times 1. Okay, cool.
Mm-hmm.
This is 6 times 4,
I'm writing it, it's just the numbers.
I'm gonna write this. I'll take these arrows out too, if it's okay. No, he doesn't know arrow. 4 times 6?
Yeah.
6 times 4. That's 6.
Yeah,
That's 6 things, that's 6.
yeah.
And that's 6 is
3 times
3 times 2, which is
times
also
1.
3 times 2 times 1.
Mm-hmm.
4 times 6 is really 4 times 3 times 2 times 1.
Mm-hmm.
You're beginning to see something, another pattern that we haven't talked about yet that might actually help us here. Check this out. This one might be a little bit not so obvious. It was 24 times 5,
Yeah.
which is the same as 5 times 24. There's 24.
Mm-hmm.
24 is the same as that 24,
Yeah.
which is 4 times 3 times 2 times 1.
Mm-hmm.
So it's 5 times 4 times 3 times 2 times 1. So in other words, we can clean this up a little bit. 1 is just 1.
Mm-hmm.
2 is 2 times 1.
Yeah.
6 is 3 times 2 times 1.
Mm-hmm.
24 is 4 times 3 times 2 times 1. 120 is 5 times 4 times 3 times 2 times 1. Don't give me the number, but could we figure it out for 6 cards? Could we figure it out for 6 cards? What math would we do?
6 times
6
5 times
5
4
times
times
4 times 3 times 2
2
times 1. Can we jump to 10?
Yeah.
Can we do it with 10 cards?
Yeah.
10 times
9.
times
8,
times
7,
times
6.
times times
4.
times
3.
times
2.
times
1.
So you do that with
Oh my God, say it again.
52?
So 52, we don't actually need 51 if we do it this way, do we?
Well, we
We
do
just
need
start
to
at 52 and then begin multiplying by 1 less until we get down to 1. Now, this move is all over mathematics. The idea of starting with a number. Remember the 4, we mentioned the 4 fours lab? 98. Well, there was one in particular that we actually had to use this skill on in the 4 fours lab. Don't worry, if you didn't take math 98, don't worry. If you took it, I apologize. Just don't look at those purple hearts. When you start with a number and multiply by 1 less until you get to 1, that's called a factorial. A factorial. It used to have another name called bang, which was way more fun. Bang! So 1, this is kind of a boring one, but 1, it would be written as 1 with an exclamation point. That means factorial. Why is that exclamation point? I have no idea. Somebody has a great sense of humor in the math world and gave it an exclamation point. So when you see 1 factorial, it just means 1. 2 factorial, 2 times 1. 3 factorial, 3 times 2 times 1. This guy here is 4 factorial. 5 factorial. So when you see, there's a lot of boards in this room, I like it. We'll go over here.
Yeah.
This, didn't I? There we go, that was better. What you That's okay?
Yeah.
So if you see, actually, exclamation point. If you see some number with an exclamation point next to it in math, it means start with that number. And multiply it by one less than that number. That would be x minus one. Then multiply it by one less than that number, which would be x minus two.